Hi everyone. Today I'm going to discuss paper 1, A levels maths paper 1, variant 1, May June 2018. So let's start. Question number 1. Find the first three terms in the expansion in ascending power of x of 1 minus 2x power 5. So this is the question of binomial expansion. Okay, we got the expression 1 minus 2x raised to power 5. Okay, so we can write it as for our convenience 1 plus minus 2x power 5, because we have read this formula of binomial expansion in 1 plus x, so that will be more easier. So I'll open this 1 plus into minus 2x power 5. So this is 1 raised to power 5 plus 5c1 1 raised to power 4 to minus 2x power 1 plus 5c2 1 raised to power 3 minus 2x square. So we'll end here because we need first three terms. So this will become 1 raised to power 5 is 1. So 5c1 by the calculator, if you solve it, it will be 5, and 1 power 4 is 1 into minus 2x plus 5c2 is 10, 1 power 3 is 1 into minus 2x whole square means 4x square. So this will be 1. 5 multiply minus 2x is minus 10x plus 40x square. So these are the first three terms of this expansion. So this is our answer. Okay. Now question part 2. Given that the coefficient of x square in the expansion of 1 plus ax plus 2x square into 1 minus 2x raised to power 5 is 12, find the value of the constant. Okay, so we got the expression 1 plus ax plus 2x square into 1 minus 2 raised to power 2x power 5 can be written as 1 plus ax plus 2x square into, we just need these three terms of this expansion so that we can get the expression of involving x square. So I will use these first three terms, 1 minus 10x plus 40x square. Okay, now start multiplying. This will be, I'll first multiply this whole term with 1, then this whole term with ax, then whole term with the 2x square. It will be 1 minus 10x plus 40x square plus ax minus 10ax square plus 40a x cube plus 2x square minus 20x cube plus 80x4. Okay, so I'll just consider the terms involving x square, because I need coefficient of x square only, so I'll not discuss any other terms. So here I got 40x square, then minus 10ax square, then plus 2x square. Okay, I'll take x square common, so it will be 40 minus 10a plus 2 into x square. So this is the coefficient of x square, but coefficient of x square is 12. It is given in the question that the coefficient of x square is 12. So it means 40 minus 10a plus 2 is equal to 12. So take 10a on the right and 12 on the left. So 40 plus 2 minus 12 is equal to 10a, or 10a is equal to 30, and this will give us a is equal to 30 by 10, which is 3. So this is our answer. Question number 2. A point is moving along the curve y is equal to 2x plus y 5 over x in such a way that the x coordinate is increasing at a constant rate of 0.2 units per second. Find the rate of change of y coordinate when x is equal to 1. Okay, we are given with the rate of change of x, which is called dx by dt, that is 0.02 units per second, and we need to find the rate of change of y, which is denoted by dy by dt, is we need to find when x is 1. This is our data. Okay, we are given with this expression y is equal to 2x plus 5 over x. So I'll differentiate it. First of all, I'll write it in a bit simple way. I'll write it as 5x raised to power minus 1, because I'll take x on the numerator on the upper side. Now by differentiating with respect to x, so this will become dy by dx is equal to the derivative of 2x is just 2, and 5, and this will be minus 1 x raised to power minus 2. This is the differentiation of x raised to power minus 1. So this will become 2, this plus 5 multiply minus 1, this will be minus 5 into x raised to power minus 2, which can be written as 2 minus 5 over x square. So this is dy by dx. Put x is equal to 1 here, because this is x is equal to 1. So then dy by dx will become 2 minus 5 over 1, which is 2 minus 5, and this is minus 3. dy by dx is minus 3. Now We know by chain rule dy by dx can be written as dy by dt multiplied dt by dx. Okay, so it can be written as dy by dx is equal to dy by dt multiply, I can write it as 1 over dx by dt because I have the value dx by dt here, so that's why I'll write in this way. So put the values. Dy by dx is minus 3 is equal to dy by dt we need to find, and we have the value dx by dt which is 0.02. So take this 0.02 on the other side, it will multiply with this. So minus 3 into 0.02 is equal to dy by dt, or dy by dt is equal to minus 0.06. So this is our answer. This is our answer. Question number 3. A curve is such that dy by dx is equal to 12 over 2x plus 1 whole square. The point 1, 1 lies on the curve. Find the coordinates of the point at which the curve intersects the x-axis. Okay, first of all we need to find the equation of curve from this expression. We got dy by dx is equal to 12 over 2x plus 1 whole square. So we can get the value, the curve equation by integrating this expression. So first of all I'll write in a bit simple way. I can write it as dy is equal to 12. I'll take dx on the other side, so I'll also take 2x plus 1 on the upper side, so it will be 2x plus 1 raised to power minus 2 dx. So I can write it like this. Now by integrating, so I'll take integration, so dy 12 2x plus 1 raised to power minus 2 dx. Okay, so this will become y, and the 12 is constant, it will move outwards. So the integration of this is 2x plus 1 minus 2 plus 1 over minus 2 plus 1 into derivative of this function, which is 2, plus c, which is the constant of integration. Okay, now y is equal to, this 2 will cancel this 12 with 6, so this will be 6 into 2x plus 1 raised to power minus 1 over minus 1 plus c. Okay, now I can write it as y is equal to minus 6 over, I will take this 2x plus 1 downwards, the bottom of the fraction, this will be 2x plus 1 raised to power 1 plus c. So this is the equation of curve, but I need to find the value of c first. So in the question it is written that the point 1, 1 lies on the curve, so put this point by putting point 1, 1 here. So I'll put 1 instead of y and 1 instead of x because there is 1, 1. So this will become 1 is equal to minus 6 over 2 multiply 1 plus 1 plus c. So 1 is equal to minus 6 over 2 plus 1 3 plus c. This will be cancelled with this. 1 is equal to minus 2 plus c, and c is equal to 1 plus 2, c is equal to 3. So I'll put the value of c here so that I can get the final equation of curve. Okay. By putting value of C in equation 1. This is equation 1. This one. So this will, the final equation of curve will be y is equal to minus 6 over 2x plus 1 plus c, which is 3, plus 3. This is the equation of curve. This is our first answer. Now I need to find the coordinates of the point where the curve intersects x-axis. As you all know that on x-axis all the y coordinates of the points are 0. So let the point of intersection of curve on x-axis is x0, because all the y coordinates will be 0 on the x-axis. So I'll put this point in this equation so that I'll get the final point where the curve cuts the x-axis. So this will be, I'll put y is equal to 0 here and x is equal to x. So 0 is equal to minus 6 over 2x plus 1 plus 3. So take this thing on the left side, so it will become positive. 6 over 2x plus 1 is equal to 3. So I can cross multiply here. So this will be 6x plus 3 is equal to 6. 6x is equal to 6 minus 3. 6x is equal to 3. X is equal to 3 over 6. X is equal to 1 by 2. Therefore, the point of intersection on x-axis will be 1 by 2, 0, because all the y coordinates are 0 as I mentioned here. So I'll put the value of x here. So this is the final point of the intersection. That's the answer. Question 4. Prove the identity sine theta plus cos theta into 1 minus sine theta cos theta is equal to sine cube theta plus cos cube theta. Okay, so we'll start from left hand side. Left hand side is sine theta plus cos theta into 1 minus sine theta cos theta. Okay, so multiply this with this whole term, so it will become sine theta minus sine square theta cos theta plus, now multiply with cos theta minus sine theta cos square theta. Now as we know that there is an identity cos square theta plus sine square theta is equal to 1. So I can use this identity to make further formulas, like cos square theta is 1 minus sine square theta, or sine square theta is equal to 1 minus cos square theta. So I'll use these two formulas here in place of sine square theta and cos square theta. Okay, so this will become sine theta minus instead of sine square theta I'll write 1 minus cos square theta into cos theta plus cos theta minus, I will write sine theta into 1 minus sine square theta instead of cos square theta. 1 minus sine square theta. So this will become sine theta minus, multiply with cos theta, minus cos theta plus cos cube theta, because there is minus outside, so this minus will become plus. Plus cos theta minus sine theta plus sine cube theta. Okay. Now this cos theta will cancel with this sine theta will cancel with this, because they are of opposite signs. So I left with cos cube theta plus sine cube theta. This is our right hand side. So it is shown that this equal to this. This is our answer. Part 2. Hence solve the equation this is equal to 3 cos cube theta for this. So from previous part I have shown that sine theta plus cos theta into 1 minus sine theta cos theta is actually equal to sine cube theta plus cos cube theta from part 1. So I'll use this result. I'll use this instead of this in this equation. Therefore I have to solve sine cube theta plus cos cube theta is equal to 3 cos cube theta, because instead of this whole term I'll use this result. So I'll put the value of this in this expression. So I'll come up with this expression. Now take cos cube theta on the other side. It will become sine cube theta is equal to 3 cos cube theta minus cos cube theta, which is sine cube theta is equal to 2 cos cube theta. Okay. Bring cos cube theta on the left side. It will become sine cube theta over cos cube theta is equal to 2, which will become tan cube theta is equal to 2. So take the cube root. So this will become tan theta is equal to cube root of 2. Therefore theta will be tan inverse cube root of 2. So after solving by the calculator, it will become theta is equal to 51.6 degrees. So this is actually our alpha. Now from the quadrants, I'll draw the 4 quadrants here. Since tan is positive, it means we will be in first and third quadrant, because in first and third quadrant tan is positive. So this will be our alpha. (51.6), and this will be our alpha, 51.6 degrees. So as we know that in first quadrant theta and alpha are same, so this will be theta and first theta will be this one and the second theta will be this one. So there are two thetas. Therefore, the first angle will be alpha is equal to theta is equal to 51.6 degrees, and the second one will be theta is equal to, that's 180 plus this. So 180 plus 51.6, which is 231.6 degrees. So these are our answers. Question number 5. The diagram shows a kite OABC in which AC is the line of symmetry. The coordinates of A and C are 0, 4 and 8, 0 respectively, and O is the origin, means the coordinates of origin are 0, 0. Find the equation of AC and OB. Okay. So I'll just make a line here so that I can use for both equations separate spaces. So equation of AC. First of all, I'll find equation of AC. For this, I got 2 points. A's coordinates are 0, 4 and C's coordinates are 8, 0. So this is x1, y1, this is x2, y2. So I'll use 2-point formula for the equation of motion. 2 points formula. I hope everyone knows, which is y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. This formula is very useful. In this formula you don't need to find gradient, you don't need to find y-intercept, you can just put 2 points coordinates here directly and you will get the equation. So very time saving formula. So this is x1 y1, this is x2 y2, just put the values. So y minus y1, which is 4, y2 is 0 minus y1 4, x minus x1 is 0 over x2 is 8 minus 0. So this will become y minus 4 over minus 4 is equal to x over 8. So by cross multiplying, it will be 8y minus 32 is equal to minus 4x, or take 4x on the left side and 32 on the right side. So this will become 4x plus 8y is equal to 32. Take 4 common, x plus 2y is equal to 32. So x plus 2y is equal to 32 over 4, which is 8. So x plus 2y is equal to 8. This is equation of AC. Now, for equation of OB, this OB. So, for this, since I will use this line as well, this OB and AC, they are perpendicular to each other. So that's why I need to find the gradient of OB first. And for that, I need to find the gradient of AC first. So gradient of AC is y2 minus y1 over x2 minus x1, which is y2 is 0 minus 4 0 minus 4 over x2 minus x1, which is 8 minus 0. 8 minus 0. This will be minus 4 over 8 or is equal to minus 1 by 2. This is the gradient of AC. Now, we can see the diagonals of a kite are always perpendicular to each other. So, the OB and AC are perpendicular, and we know that the gradients of two perpendicular lines, the product of gradients is always 1. We know that gradient of AC into gradient of OB is always minus 1 because they are perpendicular to each other. Put the value of gradient of OC here. AC minus 1 by 2 into gradient of OB is equal to minus 1. Take minus 1 by 2 on the other side. So this will become gradient of OB is equal to minus 1 into minus 2, and gradient of OB is 2. So I got the gradient, and also this OB passes through this origin 0 0, so I got point as well, and point 0 0. So I got gradient and point, so I can use the gradient point form. So gradient point form of the equation, which is y minus y1 is equal to m into x minus x1. So put the values. Y minus 0 because x, y are 0, m is 2, so 2 is into x minus 0, which is y is equal to 2x. This is the equation of OB. This is our second answer. Part 2. Find by calculation the coordinates of B. Okay. For this we need to consult the figure again. If we see the figure, so this is the midpoint of both of this diagonal OB. So I'll use it as the midpoint. So I'll use this formula of the midpoint for OB. Let's suppose the B's coordinates are x and y, and then number 1, M is the midpoint of OB, and number 2, M is the point of intersection of AC and OB as well. So we'll use these two concepts to find the values of coordinates of B. So first of all, M is the midpoint of OB, then M is the point of intersection of OB and AC. So keep in mind, since M is the midpoint of OB, and let coordinates of B are x, y. Therefore, the midpoint formula is midpoint is and origin's coordinates are 0 0. So x1 plus x2 over 2, x plus 0 over 2, comma y plus 0 over 2. Therefore, this will give us midpoint's coordinates x over 2, y over 2. This is equation number 1. Now, M is also the point of intersection of OB and AC from the figure, you can see. So I have the equation of AC and OB. I'll write it as also M is the point of intersection of OB and AC. So I'll solve them simultaneously. I got the both equation of OB and equation of AC from the previous part, so I'll solve them simultaneously. So equation of AC is x plus 2y is equal to 8, and equation of OB is y is equal to 2x. Equation of AC, equation of OB. So solving simultaneously. So I have the value of y is equal to 2x. I'll put this value in the equation number 1. So this will become x plus 2 into, I'll put the value of y here, which is 2x is equal to 8. So x plus 4x is equal to 8, 5x is equal to 8. So x is equal to 8 over 5. Okay, now I'll put this value of x in the second equation. So from y is equal to 2x, y is equal to 2 into value of x, which is 8 over 5. So y is equal to 16 over 5. So these are the coordinates of M as well, which are 8 over 5 and 16 over 5. Also we have the coordinates of M, x over 2, y over 2. So it means this is equal to this and this is equal to this. Therefore x over 2 is equal to 8 over 5 and y over 2 is equal to 16 over 5. So this will become x equal to 16 over 5, y is equal to 32 over 5. So these, therefore, coordinates of B will be 16 over 5, 32 over 5. So these are the coordinates of B. This is our answer. Question number 6. The diagram shows a circle with center and radius r centimeter. The point A and B lie on the circle and AT is the tangent to the circle. Angle AOB is theta radians and OBT is a straight line. Everything you can see in the picture. Express the area of the shaded region in terms of r and theta. Okay. So from picture we can see that the area of shaded region is actually, this is 90 degrees triangle because the tangent and radius are always perpendicular. So the area of shaded region is the area of triangle OAT minus area of sector OAB. This white sector will be subtracted, so this is the shaded region. So from figure, area of shaded region is equal to area of right angle triangle OAT minus area of sector OAB. All right. So for area of triangle we need this AT first, because we'll use the formula 1 by 2 into base into height. So for that I need AT first. How I can find AT? I'll use here from this triangle AT, this is base and this is perpendicular. So I know that tan theta actually connects base and perpendicular. So from triangle OAT, this tan theta is equal to through perpendicular over base. So this is perpendicular AT over R. So therefore AT will be R tan theta. So please keep in mind. Now so this is the value of AT from this triangle by tan theta. This is base, this is perpendicular. So by tan theta I find the value of AT. Now for area of AOT, this is base, this is perpendicular, or this is base, or this is perpendicular. It's up to you. So I'll use the formula 1 by 2 into base into height minus area of sectors formula is 1 by 2 r square theta. Okay, now 1 by 2. So I can suppose base is OA and height is AT from the figure, and 1 by 2, the radius is OA square and 2 theta for sector. Now put the values 1 by 2, OA is radius which is R, and AT, I found the value of AT, R tan theta minus 1 by 2, OA is R, so R square, theta is theta. So this will become 1 by 2 R square tan theta minus 1 by 2 R square theta. So I can take 1 by 2 R square common. So this will become tan theta minus theta. So this is our answer, because I need to find shaded region area in R and theta form. Part 2. In the case where R is equal to 3 and theta is 1 by 1.2, find the perimeter of the shaded region. Okay, for this we need to consider the figure again. For perimeter of the shaded region, we can see there are three boundaries of the shaded region. One is AT, one is AB curve, and then one is BT. So we need to find the lengths of all three boundaries, and then we have to add them for the perimeter. So we'll find the lengths first, all three lengths, AT, AB and BT, then we'll add them. So first of all, the values for R and theta for this part is 3 and theta is 1.2 radians. So AT, I already got AT, which is R tan theta from the previous part. So put the values. R is 3 into tan 1.2. So this will give me, don't forget to change your calculator into radian mode, okay, so that your values of tan will be correct, otherwise there will be wrong values. So 3 tan 1.2 will become 7.72. This is the value of AT. Now the second, that is the arc AB. AB arc's value, the formula for the arc length is S is equal to R theta. So R is 3, theta is 1.2, which is 3.6. This is the value of AB. Now the third thing, OT. If you see, this is our picture. So This is our picture, and this is our shaded region. This is O, this is A, this is T, and this is B. So the third thing, first of all, I'll find OT, then I'll subtract this R so that I can get BT. So from this triangle, right angle triangle, OT is hypotenuse and AT is 7.72 and this is 3. So I can easily find OT by the Pythagoras theorem. By Pythagoras theorem, perpendicular square is equal to base square plus perpendicular. Hypotenuse square is equal to base square plus perpendicular square. So this will become OT is equal to square root. This whole thing will become 68.54, or OT is equal to 8.23. But I need BT because this BT is the boundary of the shaded region, so I need to subtract this R, which is 3. So BT will be OT minus 3. So OT is 8.23 minus 3, which is 5.23. This is the value of BT. Therefore, perimeter of shaded region is the sum of all three sides, sum of AT plus AB arc plus BT line segment. So AT is 7.72 plus AB arc is 3.6 plus BT is 5.23. So by adding all of them, so we'll get 16.6. This is our perimeter. So that's it for the first part of the video. I'll complete the paper in the second video. So that's it for now. See you in the second video. Thanks for watching.